Hola, probando, uno, dos, probando, uno, dos, probando. ¿Cómo están mis estimados? ¿Todo bien, todo azul? Bienvenidos, pucha, por lo menos por carácter amistoso. Enciendan las cámaras. Yo sé que ya es la última hora de la clase, ya solo nos quedan 40 minutitos. Enciendan esas cámaras. Hola, Camila. ¿Y dónde está usted, Camila? Eso no parece. ¿Dónde está? En la cama, dormida. ¡Qué barbaridad! ¡Poch! Ay, el resto de la clase, pero le agradezco, Camila, por
Ay,
eso.
mister, es que ya es jueves. El jueves es como que fuera viernes.
No, jueves una cosa, viernes otra. Imagínense.
Lo mismo, mister.
No, no, nada.
Me bajan
¿Cuál?
todos los ánimos para estar en clase.
Dele, dele, no se anime mucho. Vamos, vamos. Enciendan cámaras. Vamos a ver, Chinchilla, Valeria. Las dos Valerias, Iván, Salvador, Tábora, Enamorado, Umaña, Agüero, Sorto, Sofía, Andrade, Eduardo, Bujayo. Please turn on the camera. ¿Qué quiere decir eso? ¿A una papa? ¿Qué es eso,
No,
Camila?
mira, pero estoy viendo los emojis, los estoy poniendo, no sabía que se podía poner más.
Ah, ya digo que tiene que ver una papa con todo esto, decía yo, pero bueno. A ver, vamos, gracias, gracias. Encender las cámaras. Vamos, vamos, vamos. Miren, hoy vamos a dar tres problemitas el día de hoy y vamos a terminar rápido, pues, para que no se quejen. Pero eso va a depender de qué tan rápido enciendan las cámaras. Pucha, Salvador, ¿y dónde anda usted, Salvador?
No, mister, fíjese que ando en un compromiso ahorita.
Ya, ya. A ver, Chinchilla, Ramírez, Mesto, Güero, Andrade, Eduardo, Jean, please turn on the camera. Gracias. Imagine, y solo hay 16 alumnos, prácticamente menos de la mitad. Bueno, entonces, buen provecho, buen provecho. A mí no me molesta que coman, porque yo sé que es hora de almuerzo. Ah, no hay problema, buen provecho. Pero pocha, me enciendan las cámaras, aunque sea. En fin, pues, vamos a cambiar lo que es la cámara. The speaker, let me pin my video. And I'm going to erase. By the way, can you read perfectly well the whiteboard, please? ¿Sí? ¿Se lee bien? No se preocupe que
Sí,
los
mister.
problemas no son de ustedes, esos son de décimos. Es que lo dejé así para cuadrar, que me habían dicho que se había vuelto a descuadrar esto. Pero voy a borrar esta parte para comenzar la clase. All right. Simple harmonic motion. Da, 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 da. Bueno, por mientras voy a hacer esto. All right. The first part where the first problem today says, we're going to start with the internet. Says the problem says an Ethernet cable. And it Ethernet. An Ethernet cable. An Ethernet cable is 40 meters long. Is 4 meters long. It's 4 meters long and has a mass of and has a mass of 0.2 kilograms. 0.2 kilograms. Period. A transverse wave pulse is producing by, hold on, is producing by is produced by plucking, 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 plucking one end of the one end of the one end of the taut cable, taut cable, taut cable, period. What is the tension in the cable? Oh, sorry, sorry. The pulse makes, sorry, I forgot this one. The pulse makes, the pulse makes 4 trips down, 4 trips down and back along the cable. In 0.8 seconds. The question is, what is the tension in the cable? All right. In this problem, my dear students, we have the one singular thing we have to analyze. For example, in the period of time. But if you read the problem, the period of time in this situation mentions that pulse makes 4 trips down and back along the cable in 0.8 seconds. So 1, 2, 3, 4 trips, just like this is the cable. Like I'm going to show you. This is going to be the Ethernet cable, right? And according to the problem says this pulse has 4 trips. 1, 2, 3, and 4, right? To the point A to the point B. And according for this situation, the period of time to moving this movement since the point A until the point B, that will take around 0.8 seconds. All right, this is the total period of time. But to the main purpose at the moment, with the rewind the problems, we don't need to use the 4 times strip. So the only thing that we have to do is take only that period of time to move CA until B. For that reason, the real period of time we're going to use, we're going to divide 0.8 divided by 4, and that will be around 0.8 divided by 4, that will be 0.2 units. So this period of time must be divided by 4, and the real period of time we're going to use will be 0.2 units. Okay, the problem gave us the mass, all right, is 0.2 kilograms, and at the same time the length. Okay, why is so useful to determine that situation? Because the first thing that we have to do in this problem is calculate what will be the linear density of the cord. So the mu value, the linear density, that will be equal to the product or the division between mass per unit of length. Okay, so the mass of this cord is given by 0.2 kilograms divided by the length, and the length will be 4 meters. So the linear density in that situation will be given by 0.2 divided by 4 will be 0.05. 0.05 what? Kilograms per meters. Okay? This is going to be the first step. Second step, we must calculate what will be the velocity, the wavelength. Remember that wavelength can be calculated, or the velocity of the wavelength can be calculated multiplying the wavelength times the frequency. Okay, so because the wavelength will be moved at the same distance at the point A and B, the length of the Ethernet cable will be the same wavelength we're going to have in this situation. So we got 4 meters, and the frequency, my dear students, is the reciprocal value of the period. If the period is 0.2 seconds, okay, the frequency, the reciprocal 0.2 will be 5 units. So we got 5 hertz. 5 hertz. So this wavelength will be given by, or velocity wavelength will be given by 20 meters per second. Well, but the big question is, why is so useful to calculate the velocity and the linear density? Well, if you remember, what is the equation from velocity? The velocity of the waves can be calculated by the square root of the force divided by mu. And the force will be represents the tension. So if we elevated the second power, both sides of this equation, what is going to happen? Well, velocity second power equals force divided by mu. Mu divide passes to multiply. B squared times mu will be the tension or the force. So we got 20 meters per second, second power, and mu we got 0.05 kilograms per meter, and we got the force of the tension. So the answer will be 400 times 0.05. The answer will be 20. 20 what? 20 newtons. And that's it. That's all that we have to do in this problem. Question? ¿Pregunta? Pues está todo claro. ¿Entendieron por qué utilizamos tiempo 0.2 en lugar de 0.8? ¿Mm? ¿Sí o no? Ah, níate. Ah, bueno. Acuérdense, se dividió porque usted no quiere los tiempos de ida y vuelta, solo quiere nada más con un tiempo suficiente. Y como se mueve a velocidad constante, por eso es que el tiempo lo divide entre 4. Y sabes de dónde saqué los 5 Hz, ¿verdad? Recuerde que es el valor recíproco del periodo, o sea, 1 sobre 0.2, que eso nos da 5. Bueno, vamos a confiar que sí, mis alumnos sí entendieron. Bueno, vamos a buscar otro problemita. Okay, the second problem. Problem number 2 says, transverse waves with a speed of 50 meters per second are to be produced on a stretched string. Stretched string. Period. String. A 5 meters length a 5 meters length of a string with total mass of 0.06 kilograms is used. Period. Letter A. What is the required tension in the string? Okay. In letter B, calculate the weight speed if the tension is 8 newtons. Well, all right. First of all, we want let's going to determine the data. In the part 8, remember, we have a speed of 50 meters per second. All right. When we have a length of 5 meters and the string has a mass of 0.06 kilograms. So they're asking for what will be the tension or the force. All right, let's go to start working with the first value from the data. Remember step number 1, we can calculate the linear density. Mu, linear density is the mass divided by the length. So the mass is 0.06 kilograms and the length is 5 meters. So the linear density will be given by 0.06 divided by 5. So we got 0.012. 0.012 kilograms per meters. This is mu. But remember, they're asking for what will be the required tension. So remember, we have the given formula located over here. The force can be calculated multiplying velocity of the second power times mu, using the same formula that we solved already a few moments ago. The velocity will be 50 meters per second. Second power times mu, in mu will be 0.012 kilograms per meter. So the force in this case will given by 50 second power times 0.012. So the tension will be 30 newtons. This is in the letter A. How about the letter B? And the letter B says, okay, well, if that's the case, calculate the speed if just in case the tension was 8 newtons. Well, velocity, remember, square root of the force divided by mu. So we got the force, 8 newtons, and we got mu, that will be the same, it's a constant, 0.012 kilograms per meter. So the velocity 8 divided by 0.012 square root, and the answer will be 25.82. 25.82 meters per second. And this is going to be the solution set of the problem number 2. And just to make you a promise, because I said that we're going to solve in 3 problems. Da-da-da. Well, the last one. We got in the last problem is given by the next equation. The position of 0.3 kilograms objects attached to a spring is described by x equals 0.25 meters cosine 0.4 pi t. Pi t. So that we have some questions. Letter A says find the amplitude of the motion. B, the amplitude of the motion. B, the spring constant. The spring constant. What else? The position of the object, C. The position of the object at T equals 0.30. And letter D, the velocity, the speed of the object at T equals 0.30 seconds. All right, guys. Just to make a promise, this was the last problem we're going to solve. Okay, let's going to do it. The position of 0.3 kilograms object attached to a spring is described by the following equation. X equals 0.25 meters cosine 0.4 pi t, okay? So we have a few questions. What will be the amplitude of the, what will be the amplitude of the motion? Well, my dear students, always when we have a simple harmonic motion equation, right? It doesn't matter, we're talking about sine or cosine function, that number who's multiplying sine or cosine always will be the amplitude without exception. So the amplitude will be given by 0.25 meters. All right. This is going to be the amplitude. What else? The spring constant. Okay, to try to find out what will be the spring constant, we must to determine what will be the value from omega. Remember omega is given by the equation 2 pi times the frequency. Okay, 2 times the frequency. And omega always will be given by the number who's multiplied in angle. Remember that angle, we have cosine parentheses 0.4 pi t. So we're going to discard obviously the letter t, and omega will be 0.45. So replacing 0.4 pi over 2 pi, that will be given by the frequency. So the frequency will be given by 0.2 hertz. And why? Why is so important to determine what will be the frequency? Well, simple, because we know that frequency, remember what will be the equation from the frequency. Everyone who's wanna be reminding, 1 over 2 pi square root of what? A ver, ¿cuál sería la
K
ecuación
over
ahí?
M.
Excuse me?
K over M.
K over M, right? K over M. Perfect. This is the equation because we know what is the value from the frequency. Remember, 2 pi is divide, passes to multiply. So 2 pi frequency equals square root K over M, okay? And elevated the second power, both sides of the equation. What we got? We got 4 pi square frequency square, all right? Multiplying by the mass, and that will be the value from K. Because the mass is divided, passes to multiply. So we got 4 pi square, parentheses, 0.2 hertz, second power, and we know the value from the mass. The mass of the object will be 0.3 kilograms, and this is going to be the K constant. So let's begin. We got 4 pi second power, parentheses 0.2 second power times 0.3, and that will be equal to 0.474 newtons per meters. That will be the value from the K constant, right? So what will be the spring constant, right? K equals 0.474 newtons per meters. We had the second question. The third one, okay? We must determine the position of the object at t equals 0.30 seconds. Well, that in this case, the easier part, because the only thing that we have to do is replace the t value by 0.36. So x equals, we got 0.25 meters, cosine, bracket or parentheses as you wish, 0.45, and instead to use t, I'm going to use 0.30 seconds. But remember, at the moment we're going to apply this formula, remember, we must set up their calculator in radians. In radians. So, 1, 2 radians. Okay, we got 0.4 pi multiplying by 0.30. Okay, cosine of the function multiplying by 0.25. So the answer will be 0.232. That will be meters. So x equals 0.232 meters. And finally, the velocity. How we can calculate the velocity. Remember the equation of the velocity that will be given by velocity equals negative amplitude times velocity sine, in this case, is 0.4 pi t. So this is going to be the formula, right? So velocity equals negative. The amplitude is given by 0.25 meters. Omega is 0.45. Okay. Sine, and we can multiply, if we wish, 0.4 pi times 0.30. The answer could be sine of 0.3770. Okay, 3770. And the velocity will be given by sine 0.3770 multiplying by 0.45 multiplying by negative 0.25, and we got negative 0.116 meters per second. Ay, se me fue. Vamos a ver. Uy, 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 uy. Velocity equals negative 0.116 meters per second. And just to make a promise with you today, I told you already, we're going to do only 3 problems for today. No pueden quejarse, les prometí 3 problemas que íbamos a hacer e hicimos 3. Bueno, vamos a tomar un print screen. Vamos a mandarlos. Ahorita déjenme ver por el chat. Aquí les va. No sé si hay alguna duda, pregunta de momento, muchachos. Está todo bien, todo azul. ¿Mm? ¿Mm? Ok,
No, Mr. Ningún.
excelente. Dígame, Ana.
Sí, podría repetir por qué why the amplitude was 0.25.
Eso es por la forma de las gráficas sinoidales de seno y coseno. Simplemente el número que multiplica una función es lo que me determina el ancho, cuál es la máxima anchura que va a tener. Es como una regla general. Cuando ya miremos la clase de matemáticas, las gráficas de la función seno y coseno en específico, va a ver directamente la regla. Lo que sucede es que se supone que cuando el maestro de física enseña esto, se supone que el alumno ya debió haber visto las gráficas de seno, coseno, tangente, secante, cosecante y cotangente. Pero como yo sé cómo estaba el programa del colegio, por esa razón es que se mira un pequeño lagunita. Pero créanme que esa pregunta con bastante detalle ya se la voy respondiendo la próxima semana en math, cuando mire usted la forma o el comportamiento de seno y coseno. Pero manéjelo así por mientras. Sin importar si es la función seno o coseno, cualquier número que multiplique fuera de esa función representa la anchura máxima que va a tener, sin excepción alguna. ¿Ok? Por eso es que le puse que la amplitud es 0.25. ¿Ok?
Ok, gracias.
Dele pues. ¿Alguien más que tenga alguna otra pregunta? Perdón. ¿Alguna otra preguntita? ¿No? Bueno, si no hay más preguntas, entonces, mis estimados, podéis ir en paz. Pásenlo bien. Nos vemos mañana, si Dios así lo permite. Cuídense. Bye bye. Shalom. Take care of yourself.